Venezuela sits on top of nearly 300 billion barrels of oil, about 17% of the world's total reserves. But there's a catch. Most of this oil is so thick, so heavy, that at room temperature it barely flows at all, closer to peanut butter than liquid fuel. Ordinary pipelines can't move it. Refineries can't process it easily. On its own, this oil is almost worthless. So, to make it usable, engineers built something extraordinary. A vast steel river, thousands of kilometers long, cutting across jungles, plains, and mountains. This is the story of how humans forced the world's hardest oil to move. Please take a moment to subscribe and like the video. It really helps the channel. Moving millions of barrels of thick oil is a logistics nightmare. You cannot just put it on trucks or trains because there is simply too much of it, and it moves too slowly. For Venezuela to sell its oil, it needed a permanent way to connect inland oil fields to ports on the coast. Pipelines were the only answer. They allow oil to flow 24 hours a day, 7 days a week. But building a pipeline for oil this heavy is not like building a normal water pipe. It requires massive engineering on a scale that most people never see. Pumping this thick oil is a battle against physics. Because the oil is heavy and contains sand and chemicals, it can wear down metal very quickly. To solve this, engineers built pipes with huge diameters, up to 1.8 meters wide. The walls of these pipes are 25 millimeters thick to handle the pressure. These pipes have to survive extreme heat, cold, and the constant rubbing of the heavy oil inside. Every kilometer of the steel river must be built to last for decades without breaking or leaking. Since the oil is as thick as peanut butter, it often cannot move on its own. To fix this, engineers use a clever trick called dilution. Next to the main oil pipe, they often build a second, smaller pipe. This second pipe carries a thinner liquid, like gasoline or light oil, from the coast back to the oil fields. This thinner liquid is mixed with the heavy oil to make it more watery. This mixture flows much more easily through the long pipes. Without this helper liquid, the steel river would get clogged and stop moving entirely. The project starts in a factory. Giant steel plates are cut to exact sizes and rolled into perfect circles. These circles are welded together using machines to make sure the seams are perfect. Once the pipe is made, it is polished and checked for any cracks. Each piece of pipe is about 12 to 18 meters long. These heavy segments are then loaded onto trucks and moved to the construction site. It takes thousands of these pieces to reach from the inland fields all the way to the ocean. Before the pipe can go in the ground, workers must clear a path 40 meters wide through forests and plains. They build temporary roads so heavy cranes and bulldozers can reach the area. The land is not always flat. In the mountains, workers have to use explosives to blast through solid rock to create a deep trench. To keep the pipe safe, they line the bottom of the trench with soft sand. This acts like a cushion, so the heavy steel pipe doesn't get scratched or bent by sharp rocks. Laying the pipe is like a giant synchronized dance. Huge tractors with cranes called side booms lift the pipe segments into place. A team of up to 80 welders works together to join the pieces. They can finish about 150 welds in a single day. After the welding is done, every joint is checked with high-tech sensors to make sure there are no holes. Then, a special plastic coating is put over the weld to prevent rust. Finally, the pipe is lowered into the trench very slowly to keep it perfectly straight. Once the pipe is in the ground, it needs to be covered up. Workers first put fine dirt around the pipe so it stays safe. Then, they fill the rest of the trench with the original soil. Giant rollers drive over the ground to pack the dirt down tight. This keeps the pipe from moving when the earth shifts or when it rains. Once it is buried, the pipeline is hidden from the weather and protected from damage. It is now a permanent part of the landscape, ready to work for the next 50 years. Even though the pipe is underground, engineers are always watching it. They use thousands of sensors to check the pressure and temperature of the oil. This information is sent to a control room. If the pressure drops even a little bit, the sensors send an alarm. This allows engineers to find leaks or blocks instantly and turn off the pumps before any damage happens. This digital system makes sure the oil stays inside the pipe and the environment stays safe. While this steel river is a triumph of engineering, it is also a powerful instrument of global politics. Despite being a top oil producer, the United States still relies on imports because its Gulf Coast refineries were specifically designed decades ago to process the heavy, high-sulfur crude that Venezuela provides. Light American oil is often exported, while these specialized plants wait for the heavy barrels they were built to handle. This structural mismatch has placed Venezuela's infrastructure at the center of a global tug-of-war. Recent U.S. actions and international sanctions have turned these pipelines into more than just transport routes. They are now tools of leverage. As global powers like China increase their involvement and the U.S. pushes to secure its energy interests,
take the oil, keep the oil, drill, baby, drill.
These quiet steel tubes have become as strategically important as any army or fleet. In the modern world, the power to control the flow of energy is the power to influence the fate of nations. Today, the Steel River works in total silence. Deep underground, the thick oil flows steadily toward the coast. When it reaches the ports, it is loaded onto giant ships called tankers and sent to refineries around the world. This system is the backbone of Venezuela's economy. It moves millions of barrels of oil across mountains and plains that would be impossible to cross otherwise. Without this engineering marvel, the world's largest oil reserve would stay trapped deep in the earth. What engineers built in Venezuela is now a model for the rest of the world. The lessons learned here about moving heavy oil are now used in places like Canada and the Middle East. It shows that it isn't enough to just find a natural resource. You have to be smart enough to move it. This project proved that humans can use technology to change how nature works. The Steel River is a monument to how we use science and machinery to power the modern world. The size of this project is hard to imagine. It took thousands of kilometers of pipe and millions of tons of steel. It proves that with enough hard work and good engineering, we can solve almost any problem. By connecting remote oil fields to the global market, this network transformed the map of South America. Venezuela's Steel River shows that no matter how thick the oil or how far the distance, engineering will always find a way to make it flow. The Steel River transforms immobile underground reserves into a flowing economic engine, marking one of the largest and most complex energy transport systems on Earth. Thanks for watching Unthinkable Build. We'll see you in the next one.